Okay, hello. I hope you can hear me now. Thanks for joining to the Java today to this talk that we will be talking today about the containers. Just mentioned before start that this talk it will be 101, so it will be just baby steps on the containers technology, and we will not go so deep in this about Docker and containers in general. It's just the first steps for start working with containers. So if you have experience with containers already, I will say that in this talk we will talk only about the base concepts. So maybe you can choose another talk, but if you don't have experience with containers or you want to learn what is containers, you can stay. So, okay. Okay. First, a little bit about me. My name is Sergio Puas. I am from Chile, but I live in Poland right now. I am a senior software engineer at EPAM. Mostly I work with Java applications, Java tools, and this stuff. So I am also involved in some DevOps projects. In some case, like working with creating some pipelines and so on and stuff like that. You can find me on GitHub. There's my GitHub on the presentation, so you can find me there and follow the things that I am doing right now. There you can find things related to DevOps or also related to Java and other stuffs. The agenda for today, okay, we will be talking about what is the containers, what is Docker, this company that appear and make popular the containers. Also, we will be running a small, our first container, the basic example for run a container that you can check that everything is installed fine. Also, we will have a demo application, very basic, it's just a front end with a back end and some architecture that I will show you. And finally, we will talk about what are the next step after you start working with containers or start to using containers. So for a start, we can start giving a definition of what is a container. A container is just the same as you can see in the real life. We have containers in real life, these big boxes, you can say, and around these boxes we have different tools. For example, in this case of the image, we have the crane that is taking this box and moving from one place to another place. I don't know, it's moving from the truck to some storage or to the ship or something like that. But the guy that is driving the crane in this case, he don't need know what is inside of the box. So because he is manipulating a box, he is not knowing what is exactly inside. I don't know, inside it can be fruits, vegetables, or no furniture or something like that, but he doesn't know. In the containers, talking about technology, is more or less the same. We have this concept that this container, that this box, that we put things inside our application that we want to run, and we can use different tools for manipulate this. We can, I don't know, move our application from our local environment in our computer to the, for example, the cloud or the server, some server on-premise, and so on. So we have a lot of tools that are built around this box called container. So a container is just a box, you can say, that we can put things inside and we can manipulate in a standard way. A little bit of story of the containers. This is not something that appeared in the last few years. It's more that appeared in 2000. Starting from the FreeBSD jails, you can create something like containers in that moment. Also the B server and all this technology that was on the kernel of the Linux, and it was very complicated to do this stuff. So after that, some companies starting to doing similar approach using technologies that they were creating. For example, Solaris create the zones, Solaris zones. Is more or less something similar to containers. After Google add the concepts of C groups. After Red Hat add another part to this technology that called namespace. IBM create LXC. And finally, after all these technologies that these companies were creating, appeared one company called Docker, and this company say, okay, we can reuse all these technologies that are already in use in the kernel, but for people is too much learn about all these technologies and about all these commands for run one container. So what they did they created this Docker daemon, and they grab all these technologies. So they are like a proxy for all this stuff. So under the hood, Docker is using all these other technologies like C groups, namespace, and so on. But they made the use of containers in a very, very easy, as you can see. After that, after a few years, also a lot of companies are starting to doing things similar like Docker did it. So they were creating some another tools for create containers, for create these processes, and for make a standard between these companies, it appeared this Open Container Initiative. That this Open Container Initiative create two specifications, one for the runtimes and one for the image. So all the companies that wanna create new tools that manage or use containers, they can use this specification, so it will be a more standard. Okay, what is a container? Talking about specifically containers, the containers allow us, like I said before, allow us to isolate applications from each other. So we can have the application A and the application B running on the same machine, but the application B doesn't know that it's running together with the application A. So they are isolated. Also, we have the benefits that we can package these applications of software in standardized units, and this allow us to make standard deployments, standard shipments, like moving from our machine to another machine, like coworker laptop or something like that, or the servers or the cloud, and we can move it easily because our application is packed on this box, in this container. So containers or Docker containers also, they are more or less everywhere. You can find it in all the cloud providers. I don't know if you go into Amazon or Google Cloud or Azure, you will find the support for Docker for containers. So you can move easily develop one application using containers on your machine, and after you can move it to the cloud very easy. Okay, but if you listen to the definition, you can say, okay, containers is something similar to the virtual machines, Yeah, in some ways, yes, they are a little similar, but they are totally different from the point of view of the technology, because you can say that containers are an abstraction of your application, of the application layer. Instead of the virtual machines are an abstraction of the physical hardware. What is the difference? Speaking about technology, virtual machines use something called hypervisor that is in the middle of your infrastructure or your main operating system. And on top of this, you run another operating system, like the guest operating system, as you see in the image. And on top of this, you run your application. So you are starting an entire machine. That is the name, virtual machine. So you need all this stuff for run your application. In opposite side, Docker runs directly on top of the kernel. So we don't need to run a guest operating system. We can run directly to the on the kernel. So we have these applications that they are processed on the kernel, and Docker is in the middle, being the proxy for all these instructions that we need for start containers. Containers and virtual machines can work together. Of course, this is the common case that you will see in a lot of in the cloud providers, or if you have some on-prem servers, you will see this architecture mostly. Like you have different virtual machines, and on top of these virtual machines you install Docker, and you can create a different architecture, like with Docker install it on virtual machine, or you can install some bare metal and install Docker there also. So you have all these combinations that you can do there. Okay, so we were talking about containers, and also I mentioned it about this company that appeared called Docker, that made for our life more easy, because he created this wrapper or this proxy for all this stuff that we saw. But what is Docker itself? Docker is a software container platform that if you ask to different roles or different people, you can have different opinions. For example, if you are asking to developers, they can say that, okay, Docker it's a tool that eliminates the work on my machine problem, because you can use Docker in your machines for run the environment that you need. I don't know, for example, you need a database, you need your application, so you can use Docker for run in this stack. And if, for example, I don't know, a new joiner is coming to the project, you can say, okay, this is the Docker compose or the Docker file. You can run it in this way. You don't need worried about install all these another dependencies, because everything is packed in one package. For another side, we have the operators, and they can have a different definition of what is Docker. For them, Docker it could be a tool that made them run and manage app in an isolated way, and use better the resources of the machine. So they can have better management on the resources of the infrastructure that they have, and they can have very isolated these applications each others. And finally, for enterprises, Docker it can be a tool that enables them to create agile software delivery pipelines, because it will be very easy to have a standard way for move one application from your dev environment, passing from all through the environments like QA until production. It will be very easy with Docker move these containers from one environment to another environment. talking about what is itself or what technology is inside of Docker. Basically, Docker it's a daemon, long-term process that you can find in your machine, and this daemon, his role is communicate with all these and other tools that we read it in the kernel. For example, I don't know, communicate with the namespace, create namespace, using C groups, user and IP tables, and so on. All these commands, all these configurations that are going to the kernel, all these instructions, the Docker daemon is in charge of translate this to the kernel and run it the containers that we want to run. On top of this Docker, this company, they created a REST API. This is a RESTful API, so you can find all the endpoints and all the requests and response that you will have in this API in the documentation of Docker. You have a lot of things that you can do there, and this basically exposes all the things all the resources that we need for use containers. And on top of this, also Docker create this Docker CLI that makes us more easy to use Docker, because we can run things like Docker container run hello world, and this it will call the API, this REST API, and the REST API will pass this instruction to the Docker daemon, and the Docker daemon it will do the magic for create all these containers. The four main resources that we have here are the networks. The network works as the same that is in regular life. The network, we have IPs and we have routes and so on. So you can configure your network according to your application. We have the containers and the image. These two resources are pretty close, because image, you can say it's a read-only template of your application. This image has all the instructions for run your application, but this is a read-only template. But when you are running this image, you are converting or making a copy in runtime runnable instance of your app, and this is called containers. So basically, if like in programming, you can say this is like image is the class and container is the object. So you can think in that way. And also the containers are ephemeral, so if you write things inside of the file system of the container, when this container die, you will lose everything that was inside. So for resolve this issue, because for example we have containers that are running databases, and when you are running databases, you expect that you have persistent file system. For that, we can use the volumes. Volumes work as the same as shared folders. You can mount some folder or file system in the container, and you can write there, and you will have persistent file system. Yeah, that are the four. There are another resources also in the Docker REST API, but these are the main ones. The ecosystem of the containers, basically you can put in a container wherever you want. I don't know, you can put databases, you can put a static website, some UI front-end application, some even, for example, binaries, you can put it there. I don't know, CLIs, for example, the CLI of Amazon, you can put it there inside and use it from the container, so you don't need to install it in your machine. You can use it directly from the containers. Also, these containers that you will put in this container, in this box, and you will be able to run it everywhere, or mostly everywhere. like, I don't know, running on your machine, on your laptop, running on the QA server, on the cloud, on-prem, and so on. I don't know, if you find on internet, you can find a lot of people that is running containers on Raspberry Pi. So this is one example that you can do. I don't know, create your own cluster or private cloud with Raspberry Pi, something like that. Yeah, this is that Docker showing in their website. They say that Docker enables to build, ship, run any app anywhere. So we can move it easily from dev to any server, any cloud, or so on. We can put anything, like, I don't know, SQL server, some Java application, so Node.js application, and so on. On top of this, it will be on top of the Docker or the container system, and we can run this on Windows or Linux and so on. And we can run it physically in virtual machines, as we saw it before, or even in the cloud. Also, we have a lot of tools that are built on thinking on containers. We have different kind of tools. For example, we have operating systems that are focused on containers, like I don't know, CoreOS. That is something that is made it for containers. We have, I don't know, service discovery, orchestration, system integration, a lot of tools that are thinking on using with containers. Okay, so we will run our first container, the most basic example for containers. So after you install Docker in your machine, you can run this command, call it docker container run hello world, and this will start all the life cycle of a container. So if you see, I will show you here. So here I have my command, and I will run this. So I am telling that I am telling to Docker, okay, I want to run a container called hello world. In this case, you see that it says enable to find the image, enable to find the image hello world locally, because we have a repository locally. But if Docker doesn't find the image locally, he will try to go into some remote repository. In this case, by default, Docker have a website called Docker Hub. In the Docker Hub, you can find image of a lot of software. I don't know, databases, some, you know, JDK also, Maven, and so on. You can find different software that you could need. You can go to Docker Hub and try to find it. So when Docker doesn't find the image locally, he going to this Docker Hub. As you see, there is pulling the image from the Docker Hub, and it's downloading the image to our computer. When this is done, so here is doing the pull. When this is done, he say that the image was downloaded, and he ran this image in our operating system. In this case, this image has this message that you can see here, and if this appears, it means that everything is okay. So this is the most basic example of containers that you can find, and this is a very nice example for test if everything is working fine after install Docker. So okay, now I will show you a demo application that I have. It's with some architecture. This is, you can find the source code in GitHub in that URL. If you are interested, it's basically a front-end application with some service, and on top we have the reverse proxy. I will show you now. the architecture of this. So okay. As can you see in the diagram that I added here, basically this is my infrastructure that I have or that I need to create. So the user is making a request through the reverse proxy, and the reverse proxy will resolve the URL that it will be for the UI service that we have, or if it's for the backend service, in this case the service that I have there. And also my service needs a database for store all the requests that the user is requesting. So for purpose of this application, I am using this stack as reverse proxy. I am using a tool that is made it thinking on containers. It's a reverse proxy called Traffic. For the UI, I am using Angular 7. For the backend application, I am using a normal Spring Boot application. And from the database, I am using the MongoDB database. So basically, you can download this source code. You will need build your image, and for build your image, you will have a file in every project. In this case, I have two projects, the UI and the backend. You will find this file called Docker file. In the Docker file, you put the instructions that you need for build your image. So in this case, I say, okay, I need to use Maven. This version of Maven, this specific version of Maven with the JDK 8. And I will, I don't know, execute the Maven package in this case. And I will create the application that I build. I will compile and build the application that I want. After that, I will put this jar in this case in this path, and for run the application, I say, okay, the entry point or for startup this container, you need to run java -jar the path to our jar or our application. So when you are running this Docker compose build, you will run this. You will build this application, and after you have the Docker compose app -d, that this will actually run all the containers that we want. But you can ask, okay, but here I am seeing a new command, this Docker compose. What is this Docker compose? From where is coming? Okay, Docker compose is another tool that the Docker company also created that enables you to create your set of containers. So you can create a file, and this Docker compose tool will read this file and will start all the containers with all the configuration that you put it in that file. So if you see here in the root of the project, we find this file called Docker compose. That is the definition of all the containers that you needed. In this case, you see that here I have this tag services, and in this under this tag, we will have all our containers that we need. In this case, as you can see before, we needed the reverse proxy, the UI, the backend, and the database. So you will find here the same components that I have. In this case, I have the database that here I am using. Okay, for the database, I will use MongoDB, this image. I will expose these ports. I am adding some volumes for persist the data that MongoDB will save. And here you can also add some labels that is needed by traffic itself. This is part of configuration of traffic, so it's something specifically to traffic. Also for the UI, here I have my UI application. Here I have some labels for traffic also. So I say, okay, this application is listening on the port 80. You need to use this rule for resolve the URL that you need resolve in the reverse proxy for redirect to this container or this application. The same for the backend. Here I have my backend application. Here you can also use environment, and this environment you can pass some configuration that you needed for your application. For example, in my case, I need set the Mongo host, or where is the host name of our MongoDB database. In this case, when you are using Docker Compose, by default, the host name of the container, it will be the name of the service. In this case, DB, that I put it DB. So the host name for the DB, it will be DB. So in this case, I am setting, okay, environment, the Mongo host, it will be DB because there is the database. You can find the database there in this host name. And also here I have some labels for traffic that, okay, this application, this backend, it will expose the port 8080. Here you can find the application running. And here the rule for redirect, all the requests that come with this path prefix, you can redirect to this container or this application. And finally, I have the reverse proxy that here is a definition of traffic. Here he will be listen the Docker API and so on, and he will this traffic or this container, it will expose the port 8080 and 8080. So if we want to run this application, we will run the Docker Compose app -d. So this is the same command that you saw it on the README. And when we are executing this command, the Docker Compose tool will read this file that we saw it, and he will start to create all this configuration that we had there. So in this case, he create some default network. So, and after he start to creating all the containers, the reverse proxy, the service that we need, the UI, and the DB. And as can you see, all the containers are done. So now, if we go to this application, so I will go into the localhost because my application is running in the port 80. The reverse proxy is running on the port 80, and he will redirect the traffic to the correct, the right container. So in this case, this is my application, and as can you see, here I have, this is my UI application, and this data that you see here in this graph, it's coming from the backend service and from the database itself. So for example, when you are executing this, he is making a request, passing through the reverse proxy and going to the exact containers that we have. In this case, for example, here, as you can see in the URL, this is the prefix that we put it, and this is my API that I created. And this is received by the Spring Boot application that I created and I am running right now, and this Spring Boot application is connected to the MongoDB database. So as you can see here, this is storing these options, the response of the options, and here is adding and getting this information from the database and from this API. Okay, so that is all the demo application that I want to show. And yeah, and finally, okay, and also we don't want that when we are running our containers, this happen that our ship is going is crashing or exploding or something like that. Okay, what is next? So I started, you can say I started to working with containers, or I want to start working with containers. There are a lot of projects right now. If you can find open source projects on GitHub, you can find a lot of nice and cool projects that are happening now. One of the most used tools that you can find right now in this moment it's Kubernetes. You will find a lot of companies that are using Kubernetes, and this is built on top of containers. Then under the hood, he is using containers, and this Kubernetes is a tool for manage. When you have a lot of containers, thousands of containers, you need something like an administrator or orchestrator for manage all these containers. So tools like Kubernetes are helping on this. Also, you have another tools for also work with containers like RKT, another operating system like Container Linux, Containerd, that is a standard way for running containers. And also another projects are going more forward, like for example Kata Containers in this case, that they are trying to create lightweight virtual machines that work as containers. So there are all these projects happening right now, and you can find, I think, a lot of another ones that are pretty cool and start to follow in this. One last advice: if maybe you wanna start with using containers, but for example in your project they are not using containers, I don't know, on the dev server, on the QA server, on production server, but you can start to working with containers locally. You can maybe create your own Docker Compose, your Docker files. You can start to go into the documentation. The documentation of Docker in the website is very useful, is very clear. So you will find all the options that you have for Docker Compose and for Docker files. And you can start working with containers locally. You don't need wait until I don't know for whom you are working. Start to using containers on production or on dev server. You can start to doing for just for a startup or set up your local environment on your machine. So also it will be something good for enable to another developers join more faster when they are coming or joining to a new project. Okay, that's all. If you have some questions, you can write it on the comments, so I will be answering these questions right now. Okay, here we have one question. Is it a good practice to run Docker Compose in production? If yes, what changes are expected in your Docker Compose file when moving it to production? Okay, mostly the recommendation is not use Docker Compose on production, because Docker Compose, Docker made this tool more thinking in local environments. Because sometimes we need to run a lot of containers that, like in the demo application that I showed, we need to run a database, I don't know, MQ server or something like that, your application and so on. So you need to run all this stuff, and for not run each container in one command, like, okay, docker run MQ server, docker run database or something like that, Docker create this tool, this Docker Compose tool, for manage these situations. For run on productions is useful. Use another tools like some some orchestrator tools like Kubernetes, or for example, Docker has his own solution for orchestration. It's not so good when you have huge processes, but it's good for a start. It's called Docker Swarm, so you can start also using that. Another question is, how do we use Docker in the context of CI/CDs? Let's say build image of the new code once any user check in any change. Okay, as I said, you can use Docker for make these agile pipelines. So in this case, for example, I know, thinking in a Java application, you can have your own pipeline, the normal pipeline that you have, I don't know, running your unit tests, checking the compilation of your application, packaging this image in a jar, this application in a jar, for example. But after that, you can add an extra step. You can say, okay, I don't want to store, for example, if you are using Artifactory, I don't want to store the jar, I will store an image. So after build your jar or your application, you can add an extra step, that this step will create the Docker image. So he will read this Docker file that you wrote before, and he will put this jar inside of this image, and you will push or add this image to the Artifactory. So after, when you wanna, for example, move this image or this container from one environment to another one, you can use the tags of the images. For example, you can have, okay, the first image that I am pushing is the, I don't know, my application version 1. So this will create one image in the Artifactory, and after, when you want to deploy it, you say, okay, I want to deploy on QA environment the my application version 1. So you can have a specifically version of this, and after you will make changes on this, you will create the version, I don't know, 1.1. So you will create a new image, and this image you will be able to deploy it in the QA server again, for example. So you are creating new images. The image are as I say, they are read only. So if you want to make some change, you need to create a new one. So you will be able also to travel in time, you can say, because you will be, okay, in version 1.1 we introduce some bug, so we can revert easily to version 1 that doesn't have this bug. Let's say that we are running an image in a cloud. Any application code got changes, a very small change. We need to start replace image entire. Yes, as I say, we need to replace the entire image, because images are read-only. So this is for because this will also enable to have this immutable image. So you will be sure what is in this image inside. It's like, for example, when you are deploying a jar application, if you wanna make some change, you need build it again, the jar, and you need deploy it again, the jar. It's more or less the same. You are not opening the jar and adding your class there inside. You need compile again and deploy it again, the jar. Can we use JSON Docker Compose? Yes, I think we can use JSON. I am not completely sure, but mostly all the examples that you will find are on YAML. So because this is a recommendation of Docker that use YAML, because it's in JSON you have another structures, and you have more keys for open and close, and in YAML you don't have this stuff. Yes. So, but because at the end this YAML, if you are debugging the code that is happening when he is reading the Docker Compose, he is transforming to a JSON structure, and he is passing all these instructions to the Docker daemon. So yeah, you can use it. You can use JSON. Kubernetes has secrets. Docker Compose has this feature. I don't remember if it's the latest version, but as far I know, it doesn't have this, because okay, this is the Docker Compose is thinking for running locally. So when you are running in these another tools like Kubernetes, these tools are thinking for run on production. So there you will have all these another features like proxies inside, routing of some requests, auto scaling, and all this stuff that you will not find in Docker Compose, because it's like, as I say, it's just mostly for local environments. There are a way to container profile details CPU usage, memory usage. Okay, yes, you can also set some limits to your containers of CPU, of memory that they will use, and you can set this on Docker Compose, uh, and you can, according to your you need what you need, you can set these values. And also, if you wanna see the usage of these resources, there are some commands in the Docker CLI that you can check the how many resources it's using, I don't know, how many memory, how many CPU is using, and so on. What will happen if any containers will run duplicated with the predefined network end? Can a container like produce copy itself during runtime? Yes, with Docker Compose, and for example, in tools like Kubernetes, talking about productions or locally, you will have something called a replication. So you can run different instance, a lot of instance, the number that you want of the same image. So for example, you can have, talking about Docker Compose, getting this example, you will say, okay, I want to run 3 instances of this same application, of the same image. So Docker Compose will run the same application 3 times, and Docker Compose, the Docker made that something nice, that he will be, you can use the hostname, and he has an internal DNS that he will routing according to the hostname to the exact container that is requesting this request. Yeah, and also you can do it. For example, you can say, okay, I wanna scale. No, I don't know. I have one container running now. That I am seeing that I need 5 more. You can do it this. You can use the scaling option, the scaling feature that Docker Compose has. You can replicate your containers on runtime. The same is happening, but in a more, you can say, professional way in tools like Kubernetes. You have all these features, for example, auto scaling. Okay, you say when the containers is using the 50% of the CPU, okay, run a new one. So you can do these rules but in tools like Kubernetes, because these are biggest tools. Docker Compose is just smaller. It doesn't have all these features. How difficult is changing is implementing Docker for some legacy apps? Yeah, in my experience, it depends of the application. If you have, for example, Java applications, I didn't have too much problems, because basically you need around the jar, so you need the Java RA only, Java RE only. So, but for example, for another application, I don't know, something very legacy, that you need a lot of dependencies and all this stuff, or very old dependencies, it could be a little challenge. But mostly I didn't have some problems. The only thing is that in your Docker Compose, you will need configure all the instructions that you need for this application run. For example, if you have some legacy application that need a specific library on the kernel or something like that, you will need install this specific version of this dependency or this library in the Docker file. Okay, I think that is all the questions that I saw. Yep, I think we are fine. Thank you for joining to this talk. That's all. I hope did you learn something. Thank you so much. Bye bye.